All right, here we are, ITS148. It's January 17th, and let me switch to sharing my screen. Share this one and optimize for full. Probably can't see this at home. Share. All right, so the ITS148. Okay, so you may have noticed, you may have gotten my email where I've combined the two sections, and unfortunately, you know, I should have asked them before the semester started, and so everything you submitted got deleted. However, I downloaded everything. Here's my student account, and you'll see in my student account, I actually, so this is what you notice for mine. It says it's been returned. Well, really, it wasn't returned. When I gave you back your attachment, when I gave you back your assignments, I had to attach it at the instructor's attachment. The only way I could attach it as an instructor's attachment to your account personally is by releasing it back to you again. And so, for those of you who did hand in something, quite a few of you did. That's where you'll see it. And so I'll probably get around to grading these things this weekend. So I was not able to grade them. There are quite a few of you, but I'll get to that this weekend. And for the tests and quizzes, I actually was able to download your scores, and actually I was able to look at how you answered each question. And it was too much for me to actually go in. No, actually, I wasn't able to actually go in and put your answers for each question in. But what I was able to do was to add how many points you got to your score of 0, because you all have zero score. So if you look at your score, like in the Dropbox, in the Gradebook Classic, if you will see the last score that you got, and but if you did not get all the points on the quiz, and you want to continue and you want to retake it, which you can, because none of them are really due yet. In fact, I extended the due date for the first set of quizzes just in case. You have till next week. You can go ahead and do that, and I will figure it out. You may end up with a score higher than the total score, just because the way I added your score in, I just added it to 0. So if, for example, you got 8 out of 10, then I put your score in as 8, or as adding 8 to your score of 0. But if you go back and you retake it and you get 10, then you might end up with a score of 12 out of 10, and I'll recognize that and be able to correct that to a 10. So don't worry about that. But if you do see that you get a score higher than the total number of points, then you can email me if you want to, or you can leave it. Who knows? I might not catch it. And so here it says, this is my comment. I resubmitted your assignment just so I have it, and so you have it. For your Dropboxes, I actually went in and downloaded your Dropbox stuff, and when this new group Laulima page appeared, I went in and added your Dropbox stuff back again. It was pretty easy, except for one of you actually had another folder in there with the assignments. And so very organized. But anyway, if your Dropbox was not restored properly, I'm sure I still have your file, unless I just missed it, but I don't think I missed it. The other thing is I wanted to mention is I have this email archive now. And so when I send out emails to the class, I'm going to send them to its148@laulima.hawaii.edu, and you'll get it. I can just do that from my email account. And So you'll see the email coming from me. I don't think you can reply to that. No, well, you can reply to me, but I don't think you guys can send to ITS128 or 148 at lalima.y.edu. Anyways, the advantage of that, of course, is that all my emails to you will be archived. That's useful for, especially for the online folks, if you, for some reason, have to zone out for a couple weeks and go to a funeral or whatever you need to do, come back and it should all be there still. All right, what is this? Oh, I think I signed up for both of them. That's why this is here. In the resources, we have, this is 148. So it's the videos, I guess, is the important thing. Here are the videos. I actually, I sent out, I noticed only 4 of you have looked at this video, 5 of you have looked at this video. When you're doing problems where I give you a bunch of statements and then you're supposed to tell me what the result or what the value of a particular variable is after all the statements have executed. You know, there's like 11 of those questions in the 4th quiz, and there's a bunch of them in the 5th quiz. There's actually more in the 5th quiz. This video explains how you can easily just figure out the answer. And I kind of intended it to be that way, kind of to get you used to, you know, you want to figure out if something works or not. You can just open up a brand new project, just paste in a little bit of code and execute it, and you can see if it works. And so, as you may have noticed in quiz 4, you're messing around with decimal, integer, doubles, singles, all the different kind of primitive data types for representing numbers, and it's similar to that first rolling assignment that we had last semester, where we learned the differences between decimal and double and so on. So it's just more of that, and instead of trying to figure out what the anything, operator precedence, what the type of a variable is when there's an assignment statement, when you're assigning it a value from an expression that's got different primitive types, what is the result? And so this video is good at it's real quick. It's only 3 minutes and 20 seconds long.
Hi everybody. This is a short video to show you a trick for figuring out the answers to questions involving
You notice I'm wearing the same shirt I was wearing Tuesday. I made this yesterday. Oh, look at my hair. I didn't notice that. All right, so today we are, where are we today? Today is Thursday. It's this day, so we're starting chapter 4. So chapters 1, 2, and 3 are basically, just getting you started, and just like introduction. And then, there's 4, 5, 6, 7, 8, 9, where we're just going to be spending 2 days per class. So let's bring up chapter 4. Let's bring up the chapter 4 quizzes, chapter 4 slides, and first of all, let's bring up the slides. Chapter PowerPoint slides, chapter 4. I'm going to save them someplace. I would like to save my DOS space. So let me just do this. View downloads, okay. Okay, all right. Let's see, downloads. New window, open in a new window. This one here. Since I'll be using this next time also. And I got my got my Vital Source book renewed, vitalsource.com. Log in here. I got that right. Yes. And it is, by the way, I think this is well, anyway. Oops, wrong book. Wrong book. This one. So we are in, how do I make this smaller? I'll accept and close. So we are in section 1 was Visual Studio, Forms application, yeah, simple stuff. Chapter 4 is in section 2, how to work with numeric and string data. Built-in value types, how to work with strings, how to convert data types. We've gone over all this earlier in the last semester, and so for the assignment, why don't I just show you the assignment here? We're still working on that. We're still fiddling with this invoice total application, and so I ask you to, first of all, you make this. I think you see, what do you do that's different? Wait a second, where are we here? These are the, this is not the assignment. Where's the assignment? Oh, exercise, I want exercises, what am I doing? Go here, and go back, oh, okay, this is it. So here, the first exercise is we modify the invoice application, and let's see, do I give you these, do I give you these, open the application that's in this directory. Do I give you those directories? Let me see if I do. I'll be in here. If I don't, I'll certainly give them to you. Let me see. Exercises. No. Oh, maybe exercises. Chapter 4. Oh, okay. Oh yeah, here we go. Yeah, here they all are. Well, anyway, you can look at that. I might even give you the solution. I hope I don't. And so, so you're gonna run the application, verify this and that. Oh, okay. The first one is we're dealing with you know, converting strings to or you know, parse int, or you know, parse or decimal parse, and you know, that kind of stuff. Well, so it tells you to enter $1000 into the text box where you're supposed to add the subtotal, and it's not going to work because there's a $, and an exception occurs, and then modify the code so so you use the 2 decimal method to convert. It still works the same. See what's next. And yeah, so you do that, and so that's very simple. That's kind of like similar to exercise 2-1. Just very simple. And then this one though, you're going to do a little bit more. Okay, so here we actually add some extra stuff. So if we go and look at what the 4-17, let's find. What is here? This is the basic one. This is the basic one. So yeah, you'll use these things. And then the second one, okay, and the enhanced one, this is figure 17 or 4-17. This is 4-17 here. So here we are using, I guess we're not getting into the parsing stuff yet, are we? Converting to decimal. Converts text to decimal. We're messing with rounding. Two string. Okay, so we don't get into that other stuff till later. So you have to make this, okay, and it gives you the code for this. Yes, it gives you the code to make the form like this. So you're going to take this other form here. You're going to take this form, which is, you know, you just follow the directions. And then you're going to add this where as you enter in subtotals and do this calculation, it's going to save them, or it's going to keep a running. It's going to keep a running sum and a running count. A running sum and a running count, so it can compute the average and the total. So it displays out here, you know, as you're going along, it displays the number of invoices you've asked to calculate the total, and it'll give you the total number of invoices. So this is the sum, and then it computes the average. The average is the total invoices divided by the number of invoices, of course. So that's like this is like the first half of exercise 4-2, and then after that you're going to do after that it asks you to add 2 more text boxes and have a largest invoice and a smallest invoice. So as it's going along, you're going to also keep track of the smallest invoice and the largest invoice. This is easy stuff, so you know we'll go over it. And I didn't add any more than this. So I mean I could have later on in the semester I'll actually, you know, add some more little things to have you think a little bit more. But this has you think a little bit. I mean, it tells you to find the smallest invoice total, use mathmin method to compare each invoice total to a variable that contains the smallest invoice. And so if as you're going along, yeah, you don't really need to use that, but as you're going along, if you encounter if you encounter, okay, so you're storing the last invoice. The first invoice you enter, you can just store that number. The first invoice you enter can you can store as the largest invoice and the smallest invoice, because there's only one invoice, so they're both large. It's both the largest and the smallest. But then when you enter a second invoice, you compare that invoice with the smallest invoice, and if the new invoice is smaller than the smallest invoice, then you replace the smallest invoice with the new invoice. And if the I just want to make sure while I think of it, make sure I'm okay. I am sharing my screen and I am recording. Okay, and then you also check to see if the invoice you just entered is bigger than the largest invoice that you have stored, and if it is, you replace your stored largest invoice value with the invoice that you just entered. All right, so that's assignment 2. So let's go through these. Let's go through these slides. There's 55 of them. I don't think we'll get through all of them. This is a two class chapter. So maybe we'll do half of it or maybe we'll try to do 3/4 of it today, and then on Tuesday we will finish up, and then we can start doing the exercise. The exercise is going to be pretty fast. So in this chapter, we learn about how to work with numeric and string data, numeric data and string data, and how to, go back and forth. And so first, the objectives are for the applied stuff, given an arithmetic expression and the values for the variables of the expression, evaluate the expression. And so, maybe because maybe the reason none of you have watched the video is because you don't need it until chapter 4, and today we're just starting chapter 4. So, there's like there's like 11 quiz questions where you're given some assignment statements, and then you're given an expression, and you're supposed to say what the value of the expression is. And the point is you can just write a little dinky little program to tell you what it is, and then you get the answer. And as you watch the video, you'll see that. Use numeric and string data as needed within your application. You know how to use it. It means you should be able to do any of the following: declare and initialize variables and constants. That's just declaring variables and initializing constants. You're able to write the code for the arithmetic for the expressions. I think there's actually a question where if you want to embed an expression in another expression, what do you surround that expression with? And of course, it's parentheses. But so we're getting pretty basic here. It's basic algebra. How to use static methods of a math class, and we're going to use min and max, I guess. How to convert data from one type to another. Anything you type into a text box is going to be text. Even if you type in 1, 2, 3, 4, 5, that's 5 characters. It's not 12,345. It's 5 characters. And so how do you convert that to 12,345? That's conversion. Scoping. You recall that if you have a method and you declare variables inside the method, then outside the method, you have no idea what those variables are or what they are or what their values are. However, if you declare variables outside a method, then inside a method, you do know what those outside declared variables are and their values. Enumerations, we never covered enumerations last semester. It's very simple. All enumerations is if you have a variable that can take on the value to the enumerated values are just like there's the first one, the second one, the third one, the fourth one, the fifth one, and so it's a way of giving text names to the values, 1, 2, 3, 4, 5, or however many you have, and you'll see that. And then working with nullable types and null coalescent, we'll see what that is. For objectives, we want to know, or we want to be able to distinguish between a variable and a constant. All that means is variables can change as the program is executing, whereas a constant is declared and defined at the very beginning of your program, and then after that, it's not a variable anymore. It's just like replacing the name of the constant with the value of the constant. That's all it is. And that has all kinds of ramifications. It's stored in a different place in memory and all that kind of stuff. There's naming conventions, and so we're going to learn what Numeric recommends as naming conventions. And then these data types, of course, we already know what these data types are. Describe any of these terms, what a literal value is, what a null value is, empty string, concatenate, append, an escape sequence, all this. We're going to learn about that. Order of precedence, if you got A times B plus C, if you have A plus B times C, you know that times, multiplication, has precedence over addition. So if you have this big long expression that's got a bunch of additions and multiplications in it, you do all the multiplications first, and then after that you do the additions. So A times B plus A plus B times C, A plus B, no, I'll do this instead. 5 plus 4 times 2 equals, first you do the 4 times 2, which is 8, and then you add the 5. So it's 13. Okay. This is not the same as, it's okay. So let me see. Right. No, I don't have to say that. Same as really this is 5 plus 4 times 2. This is a way of writing it where you don't have to worry about precedence. You just do what's inside the parentheses first. So no matter what is inside the parentheses, same as this, not same as 5 plus 4 times 2. You see, in this case, you would do the 5 plus 4 first, and then you'd multiply it by the 2. So this is equal 18, whereas this is equal 13, you see? So anyway, distinguish between implicit casting and explicit casting. In some cases, you can do implicit casting where the system knows that you want to cast, you know, kind of know what you mean, but and for explicit casting, it could be ambiguous or something, so you have to actually say what it is. And then distinguish between a value type and a reference type, and that's a little bit more, the concept is a little bit more complicated, and basically what it is it's, well, we'll see what that means, but it's hard to explain right off the bat, so we'll get to that. All right, also describe the difference between, in the ways of casting, toString, parse, try parse, and methods, so we are going to learn that. And describe the difference between class scope and method scope. A class scope is, you know, method scope is just within a scope, is just within a method, whereas a class scope covers all, you know, all the methods within a class. Okay, so here are the built-in, I guess you could say the primitive data types or the built-in value types that we already know about. But as you can see in this book, he does a lot. It's a lot more comprehensive. We only learned last time. We only learned int. Did we cover short? I can't remember if we did or not. And see, so these are the different, double is float. Number of bytes. So these are all, you can see what they are. A byte is a byte. An unsigned byte is just got 8 bits, 0 to 255. If it's a signed byte, it doesn't go 0 to 255. It like shifts down halfway, so it goes minus 128 to plus 127, and you know, 0 is in there. So if you add up all the combinations, it ends up being 256. 0 to 255 is 256 different combinations. Short uses 2 bytes, and if you think of 2 to the 16th power, 2 to the 16th power is 65,536. So if it's unsigned, it goes from 0 to 65,535. But if it's signed, the highest order bit is the sign bit. So the sign bit is going to say whether it's positive or negative, and then so that determines if this is a positive number or a negative number. It's not quite that simple, but for the concept, that's what the concept is. Integers, unsigned integers. This is a 4-byte, so it's 2 to the 32nd power. And then we've got long integers, which is 8 bytes, and so that would be 8 times 8 is 64, so that would be a number up to 2 to the 64 power, which is a pretty big number. Let's see. Million, billion, trillion, quadrillion. I don't know what's higher than quadrillion. I don't know what the name of it is. And then we also have floating point numbers. Decimal we know about, character we know about, and Boolean we know about. And so how to declare and initialize variable types. So this is the syntax. This is misleading. It's not this. This here is the data type. It should be, this is a bad way of describing it. It should be something, I would do something like this. First there's the data type, and then there's the variable name, because these actually are descriptive terms. It's not actual, this is the actual thing. This is the type, represents this, and this is the name of the variable, which represents this. And then here we are assigning the variable name to a value, to some value. What I'm doing is not important. Here we're assigning the variable name to a value. The variable stores the value that can change as the program executes. And so the naming convention is start names of variables with a lowercase letter and then capitalize each word after that, which is known as camel notation. Or we used to call it bumpy caps. So here's an example how to declare and initialize a variable in one statement. So you don't need to have 2 statements like you have back here. You can say int counter equals 1. You can do something like this if you want. If you want to, you can do that. That's what this is saying. And so here you're setting number of bytes, your floating number, you put an F after that, I bet you didn't know that. Double price, this is fine. A decimal number, you got to put an M after it. You knew that. This double, you can use this E notation. You might not have known that. This is a character, which is just a single character, and you notice we're using single quotes. Double quotes is a string, so on. And then Boolean is just true or false. And you can also declare and initialize more than one variable in one statement, as long as the types of the variables are the same. So here we're declaring 2 integers, x and y, and we're initializing them. Okay, there's constants. Constants don't change. So you put a const in front of it, and it's a constant. Is this open? And so here's an example of where, and so constants are the reason we have constants is because it's going to be some number that we use all the time, like but we don't remember what, we might not exactly remember what the number is, or we just want to refer to it by name. Like in this example, we have days in November, and let's say we want to refer to the days in November, and if we were to say 30 all the time, and then someone else comes and looks at your code, they're going to wonder where that 30 came from. But if you define a constant called days in November and set that equal to 30, and then in your code, instead of using 30, you use days in November, then that's more readable. let's say you're a chemist, you're writing a program for some chemistry application, and you want to use, you want to remember what Avogadro's number is or something. That's an example of where you'd say Avogadro's number or Avo numbers equals 6.23 or whatever Avogadro's number is. Sales tax. Sales tax is another one, and this is an example of where the constant might change. Let's say it's 2025, and they figure out that the only way they can pay for rail is they got to raise the GET up to 5.25 or something. I support rail, but I'm just using this as an example. But you may have a bunch of code around that multiplies stuff by the sales tax or by the GET, and you don't want to put 4.732 or whatever the GET rate is, depending on what island you're on. The GET is different in different islands or different counties. You just want to put GET or Honolulu GET or Neighbor Island GET or something. I don't know. But then the legislature comes along and raises the GTE. All you got to do is change one number in one place, and that takes care of it everywhere. So those are examples of when you would use a constant. And in this book, we use this so-called Pascal notation. I think Pascal was a philosopher or something. Anyway, there was a language named after Pascal. So I don't know why they call it that, but anyway, it's just like camel notation, except for you also capitalize the first letter. I think there's a quiz question on camel notation, but not Pascal, I don't think. Anyway, okay. Next, we have these arithmetic operators, and so we have, of course, addition, subtraction, multiplication, division, and modulus. Modulus is the remainder. Division will always, or divisions. Division may result in a decimal number, or may result in a number that's got a decimal point. Modulus will never result in a number that's got a decimal point. Modulus is the result of a modulo operation it's going to be an integer. These, by the way, are called binary operators because they take two operands. Binary, two operands. That is opposed to a unary operator, where if you want to represent a negative number, you put a minus in front of it. That's a unary operation because it only operates on one number. Binary operations require two numbers. These are unary operators. No, they're not. Yeah, they are. Okay, so we're familiar with. Yeah, I think we're familiar with all these. Plus, plus, and minus, minus. So here's examples of arithmetic expressions that use integers. All right, so because they're integers, sometimes this comes out exactly right, sometimes it doesn't. Okay, so the first one is going to be, we're adding two integers, we're going to get an integer. We subtract one integer from another integer, we're going to get an integer. We multiply an integer by another integer, we'll get an integer. Divide an integer by another integer, depends on what the resulting data type is. I think. You can check. In fact, let me just pop open Visual Studio here. Oh, not that one. Not that one. Visual, this one. New project. Oh, I got to sign in. All right, I'm just going to open up a new project real quick here. Windows Forms application. I'm just going to pop this on the desktop. And I don't care what it's called. It's a fine name. Windows Forms application. I'm going to double click because I want to mess with the load handler. Double click. So this is what I did in my video. You can see what I did. All right, I'm going to do something slightly different here. I'm going to put the toolbox here. I'm going to put some label. Where's the label? L. Label. Yeah. So I'm going to say, I want to make this much bigger. 18. And I'm going to say, didn't mean to do that. I want to change this to answer. And I'm going to put the answer here. And so let's go back to here, and I'm going to throw in this. I'm going to throw all this in there. Zip, zip. Throw all this in there. Copy. I want it in the load handler, not this thing. Paste. So we have this here, and what I'm curious about, which one I'm curious about is this one. So first of all, I'm gonna display out what result it is. So I'm gonna say, oh, let me name this. I'm gonna name this. Well, I'm just gonna put an asterisk there, and I'm gonna name it LBL answer. LBL answer. Okay, so that's the name of this label. I don't need to name this label because I'm never gonna write to it. This is just, you know, so I know what I'm doing, kind of thing. In fact, you shouldn't name it because then it might confuse you. Would confuse me. So I'm going to do LBL answer.text equals result 4. All right, so let's run this thing. Uh-oh, I got an error. Oh, I got a, yeah, I know what the problem. I'm mixing my toString. Gotta make it a string. There we go. Let's run it now. Bonk. The answer is 1. What did we think it was going to be? 1. Okay, what I want to do now is I'm going to do decimal result 4D equals, I'm going to confirm X divided by Y. And I want to instead write result 4D. Run. Okay, okay, so what I've figured out is that because these two are integers, then whatever the result is going to be, it's going to be an integer. So this gets stored. What gets stored there is the value of the integer. Now, if I go convert, let's see, how do, I'm not going to get ahead of myself. Let's put this down for a while. Let's continue this thing here. All right, so for arithmetic expressions that use decimal, here we're just doing the same thing in decimal, and we see that all of these calculations turn out to be with a decimal point. So do this. That right in here. And so we can do, well, it doesn't matter. All right, anyway, let's keep moving here. Okay, assignment operators, you're familiar with this one and this one, but you might not have, it might not have occurred to you that you can also do times equal and minus equal. And what this is like times equal is like this here. Let's see. Well, if you want to take some number like 5, and you want to multiply by 2, then you can instead say 5 times equals 2, and it's going to be 5. It's going to be you know, be 5 times 2. In other words, they show an example here. No, they don't. Okay. Well, anyway, this is a simple assignment statement. You know that about that. These are here's an example of assignment. See, this one, for example, is total equals total plus 100, and these are decimal numbers, and it's the same as this. See, when you see total equals total something, price equals price something, then that's when you can convert it to. You don't have to have, you don't have to have all of this. You can just put a times there, and it knows what you mean. In order of precedence, as you know, unary operators are first, and then we have multiplication, division, and modulus, and then you have addition and subtraction. So you do all these things. If you have all these mixed up in one expression, this is the order in which you do it. No matter where they are in the expression, you zone into these things first, and you do those first. Calculation that uses the default order of precedence. So this here uses the calculation that uses parentheses to order. Okay, so here, here we're just at default order of precedence, price times 1 minus discount. So this is different. This is different than this. As I said before, this is different than this because this one is going to do this multiplication first, and then it's going to subtract the discount percent. Whereas this expression down here is going to subtract the discount percent from 1 and then that value is going to be multiplied by price. In this case here, we do the increment. Plus means add 1 to it. Plus means add 1 to it. This one here, it adds 1 to it first, and then it does the assignment. This one here, the second one, does the assignment first, and then it does the plus. And the plus is on this. Here, both pluses are on the variable, but it's just that if it's beforehand, it does the incrementing first, and then it uses it. It does the adding 1 first, and then it uses it in the expression. Whereas if the plus comes after, then it just uses b in the calculation of the expression first, and then after it's all done, it does the adding 1 to it. That's why this one is different. Okay, here's how casting works. So with implicit casting, there's not really a question, so it just lets you do the assignments, and it just takes care of expanding the container for the variable. Like if you have a byte value and you want to use it in an expression that uses short values, then you don't need to do anything. So this is an 8-bit number. This is a 16-bit number. We're talking integers here. This is a 32-bit integer. This is a 64-bit integer, and this is a decimal number, which is decimals are 128, or are they 64? I can't remember. Let me go back here to check to make sure. 16 bytes. Oh yeah. Oops. Yeah, right. 4, 8, 16. Yeah. So 16 bytes is 2 to the 128. 128 bits. Wow, that's a big number. We are here. This is implicit casting. So if you have an integer and it's in an expression where it's a bunch of doubles, it's okay, because to convert an integer to a double means you just add a place for a decimal point. That's all. Same with this. Character to an integer. A character is just like this byte, and so if you want to convert a character to an integer, it's easy. You're just adding 3 more bytes onto the top, and it doesn't really change anything. So examples are this thing. You've declared a double value. The variable name is grade, and you're assigning it to the value 93. Well, this 93 sure looks like an integer, but when it's stored into the grade variable, it's going to be stored as 93.0 or something, because the grade variable can take decimal numbers, can take numbers that have a decimal point. The character A these are ASCII characters, and it's represented as 65. 65 is the letter A. It goes from, if you recall from last time, it goes from 0 to 127. The capital A is 65. I remember that. And so when you do this kind of assignment, the value for letter is going to be 65. So anyway, and then here's a explicit casting, where if you have an integer, if you declare, you see, so here it's not so clear. Here, if you were to leave off the int, then you'd get an error, because you have this integer variable and you're trying to assign a number that's got a decimal point to it. And so it's going to tell you, if you want to do that, you have to tell me explicitly that you want to do that. Otherwise, I'm just going to say, oh, you're doing an error. And so here, for example, you actually need to tell it, because you're taking a number, an integer, that's the value 65, and you're trying to say that that's a character. And it's not. It's a number. But really what you want is you want the ASCII character whose value is 65. And so that'll do the conversion, and it'll store it in there as a letter. It still looks the same, but it's still the same value. It's just that when you write it out, if you actually display out the 65, it's going to be 65. But if you display out display it out as a character, then it's going to be the letter A. So here's casting, where it adds up these three numbers, and then it converts it to an integer, and then it divides it by 3. So this, what was I going to do over here? Oh, I was going to say, result. This thing. It's this one. So let me say, I'm going to do this. Decimal result 13A, just because I want a different name, equals decimal let me see what the syntax looks like. Yeah, that's what I thought. Yeah, you got to put parentheses around the whole thing. All right, so let me just do this. Decimal A divided by decimal B. And then I want to print out result 13A. So I'm going to see what this does. What's the light bulb say? Light bulbs like this show pictures. Oh, what is it? What is the code? What it was? Rename result to result A. I don't know why it's telling me this. Doesn't matter. Okay, I want to run this, see what it does. Okay, that's a different number. That is definitely a different number. All right, so anyway, let's, so this is how you do casting. Okay, so there's these methods that you can use to help you do stuff, the math class. And so a math class, the math class is what we call a static. It's a static class, which means you can just use it. You don't have to instantiate it as an object and then use the object. You don't have to do that. It's a static class, which means you don't have to instantiate anything. You just use it, and you refer to it by the name of the class instead of the name of the object. That should become clearer to you as we go along. But so, and the math class has got a bunch of methods that we can use. And so here, there's a round method. There's a power method where it's something to the power of something. There's a square root method, and there's this min-max method. And this is how that's used. Math min and math max. So instead of using the less than or greater than, which to keep track of the minimum and the maximum, we could use that, but we're going to use this instead, just for this exercise, or for exercise 4-2. Use the math min and math max to keep track of the lowest value and the highest value of the invoices. So here's a bunch of rounding things, and here with rounding you can actually say the number of digits that you want to the right of the decimal point, and this is rounding. So rounding is 0, 1, 2, 3, 4 rounds down, and 5, 6, 7, 8, 9 rounds up. So this is going to round up. This is going to round up, round up, they all round up. No. Oh, no, never mind. This is going to round up for 1. This is going to round 7.5 rounds up to 8 because it's the 5, because of the 5. 8.5 rounds up. Well, I'm not sure about this. I mean, seems like this is not right. Copy. Believe this. Let me put this there. I'll get rid of all this. So I need this. Put that here. And let me say double A equals that. Double B equals that. Double C equals that. And double D equals that. And I got to get rid of these things. Oh, I'm going to make this a comment. Make this a comment. Make this a comment. And I'm going to see if this comes out to 23.8. LBL answer text equals B dot toString. $23.8. Oh, I wonder why that rounds to. I wonder why it rounds to. What happens if I do this? Let's try this. All right, I'm gonna have to talk to my wife is a math teacher. Maybe I should read why that works, because normally rounding doesn't work that way. All right, anyway, so you learn something new every day. All right, so I guess you have to remember that, I guess. Okay, this is power 5 to the 2 power equals 25. 5 times 5 is 25, and so on. All right. How to declare initialize strings. Here we're initializing strings, obviously. You can join strings together, concatenate them with a plus sign. Plus sign, it's an ampersand in Excel. It's pretty straightforward. It's 253, we're getting there. And appending one string to another. I call this joining. Oh, They call this appending. Okay. So that's just concatenating the two together. They're called escape sequences. I don't really know why I don't know where that term comes from, but these are characters that you can't really write any other way. It's if you want to display out a new line, you can't just put a new line. Some programming languages you can, but so you do \n, and that converts automatically to a carriage return new line. /t, \t, that converts to a tab. \r is a return. These are, depending on the operating system, a \n will accomplish both \r, \n. If you go to a new line, it's going to go to the next line, but then it's also going to return back over to the beginning of the line again. And if you actually want to do a \, you do \\. And if you want to actually put a quotation mark in there because it's a string, right? And you want to put the string in double quotes. But let's say you want a double quote inside the string. Well, how do you do that? Well, how do you do it in Excel? You put two of them in a row, right? Well, in C# and most other languages, you put a \/ in front of it. So here, this is going to put a return, and so it's going to put these two things on the code on two lines. It's going to look like this, and it's going to return. So there's actually going to be a space underneath here. And so here you're tabbing Kate, Joe, tab Smith. Next line. Kate Lewis, and I have to refresh my memory on how the \r and the \n are treated differently. They could be treated the same. Now, and this is all unique to C#. Right? This ampersand stuff is I haven't seen this in any other language. I haven't seen this in any other languages, and I know a lot of languages. So this is how you do, like, verbatim strings. You put the ampersand in front, and then it's just like the way it is. If you don't have the ampersand, then you have to put the backslashes in front there. You have to put a \/ in front of every slash, and so on. So it's just a matter of getting it right. And these are common .NET structures to define values. All right. Oh yeah, classes. All right, right. So sometimes you use the capital S, and sometimes you use the lowercase s. We'll become more clear on that. And these are the common methods that we learn for data conversion. And we're familiar with these already. And these are some static methods to convert 2 decimal, 2 double, and we do 2 string all the time, but you can do these other ones too. Here's an example of when we use parsing and try-parsing, and we're intimately familiar with parse and try-parse. Remember, we did that last semester. And here's using the conversion statements to convert a class. And let's see, where's a good place to stop? Okay, let's do 2 more slides. Here's an example of using, this is an important slide because these are the formatting number codes. When we're doing toString, and we're converting some number into a string of characters that's going to be a text string of characters with the double quotes here. This defines the format. familiar formats. So it looks like this. If you do the C, it's currency. So it's going to look like currency. It's going to put a comma in there. It's going to put a dollar sign in front. Percentage is going to multiply it by 100 and put a percent. N will put a comma and no. I think the 0 means no decimal points. This is another way of doing it. This toString, and you can use string format. And here, if you want to display out a long string, but certain places in the string you want to replace them with numbers, this is how you do that. And 0 is the first one. If you had more numbers, you could do the string format and do 1 colon or 2 colon or whatever. All right, so I think this is a good place to stop. It's 3 o'clock anyway, and we'll come back here where we actually are going to look at some code and use all of these in an example. So are there any questions? All right, that's it for today. Thanks for watching.